or in the W coordinate rather, gets just this -1 times the Z. Okay, so I'm gonna make this a 1. Make this a 1. It got even smaller, okay. Which actually makes sense, I think. That made it larger. Still doing that static though. I think this is doing the same thing that was happening before when I was like trying increasingly large values to get the fill to match the shape of the stroke. Which is bad. Why? I wonder why some of it is disappearing too. Why does that happen? I'll try and bring the far plane back. Actually, I can put the near plane. I can increase the near plane, I think, to like 5. See if that does anything. Oh. I'll leave this one. Same thing. What would cause this staticky effect? I'll put this at 16, I guess. Yeah, that's affecting a different, something totally different, I think. I don't know. Now I'm just trying, seeing how this thing is affected by everything. Don't want that to be more negative. So that's a constant -1, so I probably don't want to change that. The near and far planes, though, maybe this... It seems like the X and the Y coordinates are more important than that. Or maybe, I guess this is why it was being multiplied by this random value. 16 divided by whatever. Actually, let me try this. If I do result dot z is multiplied by 0.01, like it was up here, I wonder if that'll change anything. No difference. It makes me wish there was a way to print Z, but you can't do that in shaders, with shaders either. You can basically only use colors. It's not... I'm not totally sure if there's a way this can be like debugged. Let me go back to the matrix that I was using before. I think the only way to be able to do this effectively... Where's the result? There. To do this effectively, I have to understand why. Uh-oh, why didn't it quit? Why the X and Y coordinates are being multiplied by this. the perspective scale factor. I guess it kind of makes sense as z increases scale factor. I guess it kind of makes sense as z increases. The bottom is going to get smaller. And so things in the x direction will be moved closer toward each other. And I guess that's how it does perspective. Although I can tell, I seem to be not doing that in this case when I look at it when it's almost flat like this. All right, I'm gonna go back to this way of doing it. And I don't need the far near plane should be here. I don't need them right now. Okay, so try this. Is this using perspective? And I think it is. Might be easier to tell if I had a bigger square. Yeah, this is definitely being affected by perspective. So I guess this, multiplying by z, is the way that he gets perspective to happen. So how does perspective happen with a traditional projection matrix? It isn't handled by the... Normally it isn't handled by the... Oh no, it is handled by the projection matrix, so it should be something in here. But the value of the x-coordinate is just scaled by near divided by right. So I guess as it gets closer to the camera, the x-coordinate will move outward, so it'll scale that way. And that's why I won't need the z-coordinate. I don't see how the z-coordinate is needed here at all. But removing it causes problems. I think, if I remove the whole thing. That actually didn't cause problems. It even still zooms in and out. What does that factor do? And it couldn't be for... Maybe it's for panning. I guess that's what it did. But with a name like perspective scale factor, you would think it did something different. How's this being computed right now? Okay, right now it's doing this. Oh, it was doing this. It wasn't using that. Also, I commented the wrong thing. Moved it from the wrong thing. Okay. So this, using this matrix, should be the same as that. I'll comment this matrix. And then I'll multiply that point by the projection matrix. Okay, so this should do the same thing. And it does. And in this case, if I were to remove the z factor, and in this case, if I were to remove the z factor, so this, is it eliminating perspective? It's kind of hard to tell with one of the square being transformed and one not. I think that is eliminating perspective. I wonder if I could get this to work with a orthographic matrix. Maybe it'll make more sense that way. If I can find an orthographic matrix. Or the formula for one. Here it is, orthographic projection. So the matrix I'm using now, okay, 1 over r, 1 over t, this, and then a 1. That actually seems pretty different from what's happening here. Well, maybe not terribly different. If this is the first column, then I see something involving the x distance, 0, 0, 0. Then I see 0, something involving the height, and it's in the denominator, then 2 zeros. 0, 0. This value could be a -2 divided by far minus near, I think. Yeah, far will be a larger value, so far minus near, that'll be negative. And then the only thing is that this is a 0 instead of negative far plus near over far minus near. Maybe there's a way. Yeah, this would never be 0. Would this be positive or negative? This would be negative, I think. Let me just try putting a negative number here. Doesn't have to be a large one. Didn't really change anything. Should I make these 3s? I'll try making these 1s. Wait, these should be 2s actually. 1 over the distance to the right plane. And this is using the x, not the radius, but the width of the entire frame. So for this term to match 1 over the right, it'd have to be this divided by 2, and so that 2 will go to the numerator, so it will be like this. It seems like all I have to do is solve. Oh wait, I was editing the wrong matrix again. Jeez. Let's see, 0, 0, negative something, 0, then 0, 0, so this needs to be negative something. Okay, and that still doesn't change anything, or nothing noticeable. So I think I need to solve a way for these two to be something near negative 0.01. Although these aren't being affected by zoom. Why? Why would camera zoom not apply to these? Oh, it does when I zoom the way the regular objects are zoomed. Or the existing objects are zoomed, I should say. Or the existing objects are zoomed, I should say. I wonder where that zoom is taken is accounted for. Because it doesn't seem to be here. In the vertex shader for the fill, which is this, this is being transformed using the matrices. So where's that zoom accounted for? Maybe I could deal with that later. Quadratic Bezier geometry functions. Maybe it's that? Let's see what's in that file. Yeah, there is an orthogonal matrix. Is there a projection matrix? No. But I guess it's good there's an orthogonal matrix here. Probably not, because I know he uses a perspective projection in the end. Get XYZ to UV. And get XY to UV. Okay. Now, where's the geometry shader? There it is. So an orthographic matrix wouldn't account for zooming anyway. So that wouldn't be helpful. Let me see what the perspective uniforms are. That could be a hint. The frame shape, anti-alias width, the camera center. It has to have to do with the camera center. Which I don't think is used here. Is it used in the geometry shader? No. Which makes me wonder where it's used at all. I forgot what the function was even called. Oh, camera center. So it's declared here. It's... Wait, is it ever used? Oh, rotate point into frame. It subtracts the camera center. Is that how it accounts for zoom? And that is in the vertex shader, but it isn't being used here. Yeah, that's really weird to me. I have no idea why this zooms. Using the the uniforms from the original objects. In that case, it must not be the camera center. Although it wouldn't make sense for it to be camera rotation, would it? Oh, is that the focal distance? Meaning that it zooms by changing its focal distance? This is imported here. There's a lot. There's a lot of stuff here. True dot. Okay, so that wouldn't be what I'm using. It would be something in either the fill or inserts. So get GL position uses the focal length, focal distance. And I think that's it. So that still actually doesn't tell me why this is still being zoomed. Because get GL position isn't being called here. That I can tell. Unless it's called within an insert. It's defined within an insert. But that's all. So that's super weird. And this is in the wrapper. Okay, what happens if I don't use the matrix transformation? Okay, so now this should... Now it makes sense that it zooms in the regular way. I think, because it's calling position point into frame and rotate point into frame. This is the center, and rotation. But not the focal length. Okay, here's what I'm going to do. I'm going to try just passing a constant focal distance. And this should... I think this should prevent zoom. First I'll print what it's supposed to be. $16. I'll just pass in a 16 here. So something here should be held constant. But it's not the zoom. The zoom is not held constant. It's... No, I don't know what it is. It looks like that's perfectly fine just being a constant 16, actually. So I guess it's only the center and the rotation. I wonder if the frame shape is updated. And that's how it zooms, by changing the frame shape? Wait. Quit out of that. It does! Yikes. Okay. Oh, that's pretty bad, actually. So, normally, zooming is done by just getting closer. But the way that this camera zooms is by getting larger. And that makes me wonder if there's a way to make this compatible with the standard way of doing things. Maybe maybe I could translate it according to the size that it's been scaled up? But that would be really hard to do. Dang, man. Camera.get shape. Let me see where this is. Get width and get height. If I go to scene.high. Hey, let me see where this is. Get width and get height. If I go to scene.high. Like on scroll. It was self.camera.scale. Maybe if instead of this I shifted it, then that would work. Shift. Although it would require some math to figure out the point. Oh, it has about point, I guess. Oh, well, not really. It's scaling about that point. I would need the point that it's looking at. Though I think that will always be the origin. So then maybe when I scale, I can just move it closer to the origin and further away from the origin. Okay, here we go. Shift. And then I'd have to do self.camera. Get center. Negative that. This is going to be the origin minus the camera center. So let's just see what that does. Unexpected keyboard, that makes sense, I think. Well, it doesn't do anything. Oh, this is actually really bad. The camera that Grant wrote, it's like an orthographic camera, but it's modified to do its own perspective. And rather than getting closer, and because it's orthographic, getting closer on its own won't make things get larger or smaller. And so, to compensate for that, instead of zooming closer or zooming out, the camera itself gets larger when it wants to zoom out. And it gets smaller when it wants to zoom in. Which is pretty complicated. This will be probably really tough to switch into a standard way of doing things. Is there a PR I can look at? Save myself from this pain. Are we talking about this in general? Oh, the spam. Yeah. Dang. Well, unfortunately, I think this will take a lot more thinking about to be able to convert it to a regular camera. Because this camera is so different from the ones you learn when you learn graphics. I don't know if it'll even be compatible. Okay. But because of that, because I don't know if I'll be able to convert that, I'm going to call it for now. And then see if I can learn more about how this camera is written. Alright, so I'm going to see you guys later.